Hello students and viewers. Welcome back to my channel AV Samarpan, a journey of life science. Myself Vikash. In this video, we shall learn about the transportation across the membrane. So let's come to start the topic. We have discussed in last video about the function of plasma membrane. So transportation through the membrane is very special function of plasma membrane. So now first we shall learn about the membrane. There is two types of membrane. The first one is semi-permeable membrane. Semi-permeable membrane. And the second one is selectively permeable membrane. Selectively permeable membrane. As plasma membrane work like that of selectively permeable membrane. So now, what is the meaning of semi-permeable and selectively permeable? As the name is semi, that means half. Semi-permeable membrane is the membrane which allow the movement of water. Allow the movement of water through it and prevent the entry of solutes. So the membrane which allows the movement of water or solvent and prevent the entry of solutes known as semi-permeable membrane. The next one is selectively permeable membrane. Selectively permeable membrane a little different from that of semi-permeable. It allows the movement of water or solvent and some selected solute. So this type of membrane is known as selectively permeable. So as transportation occurs through the cell membrane or plasma membrane, it occurs with using or expenditure of energy or without the expenditure of energy. And on the basis of that, it is divided in two types. That means transportation is of two types. First one is passive transport. And the second one is active transport. The first one is passive transport, in which movement of substances through the plasma membrane without the expenditure of energy. So on which basis it works? If it is not utilize the energy, so how it works? In passive transport, movement of substances based on the concentration gradient, it moves from the higher concentration to lower concentration, and it is divided in two types. So the first one is diffusion. In this process, energy is not required. So diffusion is the movement of solid, liquid and gas from its higher concentration, higher concentration to its lower concentration. To maintain or equalize the concentration gradient. It occurs till the equalize the concentration gradient on both sides, like that. If something it is present in higher concentration, at this side it is present in very less, so that lower concentration. Movement occurs from higher concentration to lower concentration, and it continues till the equalization on both sides. So diffusion occurs in case of solid, liquid and gas in all cases. So let's come to know the examples of diffusion, where it occurs. So first, it occurs in case of solid. Think, if I erase it, it is erased very easily. But if I leave it for some days, especially in case of when something is written on the board with the help of chalk. Chalk dust is a solid thing. If it is left on the board and we try to erase after some days, it will be a little tough to erase because it diffuse in the gapping of the other solid particles or solid things. So it diffuse. In solid, diffusion is very less, negligible, but it occurs. In case of liquid, when we put potassium permanganate in water, what will happen? Just after some time, potassium permanganate distributed throughout the beaker or throughout the water, and it maintain or it equalize the concentration of that. In next case, we see it regularly in our surrounding, that is in case of gas. If we open a bottle of or cap of scent, what will happen? The smell of perfume or scent moves or spread throughout the room because of the diffusion. Think, if a student enter in the classroom with perfume that contains high concentration, in the same way as a bottle of scent present in the corner of a room, it has higher concentration, and then from that place it moves throughout the room and acquire or fulfill all the places of the room. So it is diffusion. Sometimes when we move throughout the garden, we feel different types of smell. How is it possible? Because of the diffusion, we feel the smell of different flowers because of the diffusion only. So next process is after diffusion. The second process is osmosis. Osmosis is like that of diffusion, but it is a little different from it. As we know, in case of diffusion, it occurs in solid, liquid or gas. But in case of osmosis, osmosis is a type of diffusion, but normally it is defined. Osmosis is the movement of water or solvent, movement of water or solvent from their higher concentration, from higher concentration to lower concentration through semi-permeable membrane. Semi-permeable membrane. So that in case of osmosis, semi-permeable membrane is needed. If semi-permeable membrane is not present, it is not the example of osmosis. So in osmosis, water moves only, or solvent, as water is a universal solvent, so that it moves from their higher concentration to their lower concentration as it moves inside and outside the cell through the semi-permeable membrane is known as osmosis. As we know, diffusion is the process of movement of solid, liquid and gas. It contains liquid also, and on the basis of, we can say, osmosis is a type of diffusion in which only solvent moves through semi-permeable membrane. So osmosis is divided in two types. The first one is endo-osmosis. Endo-osmosis. And the second one is exo-osmosis. When water moves into the cell is known as endo-osmosis, and when water moves out of the cell is known as exo-osmosis. So how can we define it? I shall show you this with the help of experiment in next video. But this time, if we put some resins in water, it's dried resins, these are resins, and leave it for some time, then what will happen? It absorbs water, because the concentration of water is very less inside the resin and it is very high in beaker or pot, high concentration, and inside it low concentration. So what will happen after some time? As we know, water or solvent moves from their higher concentration to their lower concentration, water moves inside it. This is the example of endo-osmosis. But in next case, that is exo-osmosis, when we put it absorbs and swells. If we put the swell resins in higher concentrated salt solution, higher concentrated salt solution, so what will happen? Salt is present in more, so that, and water is present more inside it. It has higher concentration of water, and water is present in low amount in beaker. Water comes outside, and after some time it will shrink, because if we put the swelled or swollen resins in salt solution, it lose water and shrink again. This shows the exo-osmosis case. I shall show you in next video with the help of an experiment. I hope you learned from this video. Thanks to watch this video. Keep watching and don't forget to subscribe, share and like my channel. Thank you.